Hi friends, in this video I am going to discuss about the probability of intersection of two events and the probability of union of two events. So we will start from the probability of intersection of two events. That says that probability that both events A and B occurs. Let us explain this through an example. For example, we are tossing a coin twice and we have two events. Event A is basically getting head in first toss and B event getting head in second toss. So what is the probability of A intersection B? It means getting head in both tosses. If we put all this information in a tree diagram, we can have the first toss will have head or tail with 1 by 2 probability. The second toss again will have head and tail with half probability. In this end, basically we have HH, here TH, here HT, here TT. So the probability of getting headed is basically 1 by 4. There are totally 4 outcomes. Out of 4 outcomes, there is only one time we are getting headed. So this is the probability of getting head in both toes. But mathematically we can find this probability by substituting these values in this equation. So probability of A intersection B is basically equal to probability of A multiplied by probability of B given that A has occurred. What is the probability of A here? It is 1 by 2. What is the probability of B? Given that A has occurred. Here the B and A both events are independent. So probability of B given that A has occurred is equal to probability of B. So we will have 1 by 4. So the probability of intersection of two events is basically probability of A multiplied by probability of B given that A. In case if both events are independent, then probability of B given A is nothing but probability of B itself. Now let us come to the probability of union of two events. In the union, we are looking at the probability that either events occurs. So the equation of probability of A union B is probability of A plus probability of B minus probability of A intersection B. This can be easily understood by the Venn diagram. For example, this is the A and this is the B. So what is the A union B? A union B is nothing but A all these areas plus B all these areas. So this area, it is A intersection B, we have counted twice. So we have to deduct that area again, A union B. So this is the idea behind the probability of A plus probability of B minus probability A intersection B. So taking another example, if a student enter the library, there is a probability that students will take fiction book with the probability of 0.4, non-fiction book with the probability of 0.3, and both fiction and non-fiction with the probability 0.2. So what is the probability that a student will take any book, either fiction or non-fiction? So it will be equal to probability of fiction plus probability of non-fiction minus probability of F intersection non-F. It is 0.5. So far we have discussed what is the probability of intersection of two events and what is the probability of union of two events. However, in the unions equation, there is intersection as well. So we will take an example, we will solve and we will see how that union can be dealt with. So the question says that an electronics device has two independent components A and B in series. The device will not work if either or both of the components are defective. The probability A being defective is 0.05 and the probability of B being defective is 0.02. So what is the probability that the machine will fail? And it is given that machine will not work if either or both of the components are defective. So basically we have to find probability of A defective union probability of B defective. According to our equation, it is probability of A defective plus probability of B defective minus probability A defective intersection B defective. These two terms we know already, it is given in the question 0.05, 0.02. So what is this? A intersection B. A intersection B is equal to probability of A into probability of B given A. But in case if these two events are independent, then this is equal to probability of B. So it is probability of A into probability of B. And we are given these two are independent to each other. So it is nothing but 0.01. So this is the total probability that machine will fail.